Good day, everyone. I am Kate Faraon, and I am one of the reporters from Group 1. Today, I'm going to discuss some of the subtopics of precipitation. To start with, the different types of rain gauges. The measuring of rainfall and other forms of precipitation is an age-old practice that communities had been practicing for centuries, and the device used to measure precipitation is what we call the rain gauge. A rain gauge is a meteorological instrument designed to measure precipitation in its liquid form in a specific area over a predetermined period of time. So meteorologists use this to determine the current and future weather conditions, monitor the water cycle, and refine weather condition forecast models. The, the rain gauge is also known as pseudometers and pluviometers. So we have different types of rain gauges. First is the graduated cylinder rain gauge. This is the standard rain gauge. It is used by the professional weather services, and it is used for most accurate way of directly measuring rainfall. It is widely used, and as the water gets collected by a cylindrical funnel, from where it flows directly into the graduated cylinder, or captured by a container and then poured into a measured cylinder. Two is the tipping bucket rain gauge. These rain gauges include a rain collecting funnel, two carefully calibrated buckets mounted on a fulcrum, and an electronic switch. Each time a bucket tips and switches position, a small switch sends an electronic signal. So this signal is from where the bucket tips and switches position. The number of times the signal is sent, coupled with knowledge of the carefully defined catchment area of each bucket. It provides a reliable calculation of rainfall. Third is the weighing precipitation gauge. It is a recording rain gauge. The weight of the water collected is measured as a function of time and converted to rainfall depth. The weight sensing mechanism is typically mechanical, which it uses springs. The output can be a pen trace on a sweep chart, voltage from a potentiometer, punch paper tape, or other electronic means. Weighing gauges with continuous output can be used for determining rainfall rate and depth. We have the optical rain gauge, a gauge that measures the scintillation and optical beam produced by raindrops falling between the light source and an optical receiver. By measuring the energy and selected frequency bands of the scintillation spectrum and comparing their ratios, the occurrence of precipitation, type of precipitation, and intensity of precipitation can be also estimated. The acoustic rain gauge, it is to determine the rainfall over lakes and oceans. It uses hydrophone, which it is being used to sense the sound signature for each drop size as the rain strikes a water surface. Since each sound signature is unique, it is possible to invert the underwater sound field to estimate the drop size distribution within the water. Selected moments of the drop size distribution yield rainfall rate, rainfall accumulation, and other rainfall properties. Next, we have the conversion of point rainfall. We have the mean areal depth of rainfall, the average areal rainfall. We have two common problems. The first is the computation of the probable maximum flood for larger watersheds, and also the analysis of the actual storm events in which the rainfall depths were measured at more than one of rain gauge. So we have the average aerial rainfall over an area is found using the existing station, which also uses the interpolation technique. So by extending the point rainfall to aerial estimates, and it also helps to estimate the rainfall amount at the ungauged areas. So estimation of the mean aerial rainfall. The representative precipitation over a defined areas is required in many engineering applications, whereas the gauge observation pertains to the point precipitation. A dense network of point measurements and radar estimates can provide a better presentation of the true volume over a given area. We have the station average method, the TSN polygon method, and the isohyetal method. These methods are being used in estimating the areal rainfall of an area from point rainfalls. So the first is the station average method. This technique calculates areal precipitation using the arithmetic mean of all the points of the aerial measurements. So as the definition suggests, the formula of the station average method is flashed on the screen, and the second is the Yesan polygon method. This is a graphical technique which calculates station rates based on the relative areas of each measurement station in the TSM polygon network. Since the rainfall varies in intensity and duration from one place to another, the area of each polygon, which is the AI, is being determined and the average precipitation is calculated using the following equation, where A is the total area of the watershed. So this is the diagram being used in the Pearson polygon method. Pearson polygon method, we have characteristics of the Pearson polygon method. It is unique for each gauge network, allows for areal weighing of precipitation data, does not allow for orographic effects, which those due to the elevation changes. So most widely used method for cases where there are large differences in the catches at the rain gauges and or the rain gauges are not uniformly distributed throughout the watershed. So we have the steps for the Yesan polygon method. First is construct polygon. Connecting stations with line. Bisect the polygon sides. Estimate the area of each station polygons and add all the areas. Determine the station rates by dividing the station area by the total area. And last is to determine the areal precipitation by assuming weighted precipitation for each station. So the polygons are being formed by the stations are plotted on a map to the area drawn to a scale. The adjoining stations are connected by the dashed lines. The perpendicular bisectors are constructed in each of these dashed lines. These bisectors form polygons around each station's affected area for the station within the polygon. So for the station close to the boundary lines form the closing limit for the polygons. So we have the last, the isohyetal method. This is a graphical technique which involves drawing estimated lines of the equal rainfall over an area based on the point measurement. So the formula is on the screen. And the steps for this method is first determine what contours of equal precipitation. They are what so-called isohyets, so that you will use. So draw a line between gauges that will separate by isohyets. So plot points on those lines that corresponds to the isohyets and determined in step 2. So then sketch the isohyets. Also redraw the construction into graph paper with the isohyetal lines. Then count the boxes between each of the isohyetal lines. Find the actual watershed area between each isohyet. Multiply the areas found in the step 6 by the average precipitation area. And also divide the sum of the values found in step 7 by the total area of the watershed and to get the average rainfall in the area. Station average method, the normal ratio method, inverse distance method, and regression method. So these four are the method for estimating the missing rainfall data. In the procedure used by the U.S. Weather Bureau, the missing precipitation of the station is estimated from the observations of precipitation at some other station as close to and as evenly spaced around the station with the missing record as possible. So since complete measured precipitation data are important to many problems and hydraulic analysis in design, the station whose data is missing is called interpolation, while index stations It refers to the gauging stations whose data are used to calculate the missing station. What are the causes of missing rainfall's data? So first, maybe it is the failure of the observer to make the necessary visit to the gauge. Also, the vandalism of recording gauges, the instrument failure because of the mechanical or electrical malfunctioning can also result in missing data. First, we have the station average method. The station average method for estimating missing data uses in gauges from the region to estimate the missing point of rainfall. P at the another gauge. So the formula is on the screen, and PI is a catch at the gauge I. Equation is conceptually simple, but may not be accurate when the total annual catch of any of n regional gauges differ from the annual catch at the point of interest by more than 10%. So by dealing with example, we can understand the concept further. So our group prepare examples for each method. The first example, we have the data. 10% of the annual catch at gauge X is 41 millimeter, and the average annual catch of each of the three regional gauges is within positive or negative 41 millimeter. Therefore, the station average method can be used. The estimated catch of the gauge with the missing monthly precipitation is a total of 26.667 millimeter. Second is the normal ratio method. So the formula is on the screen. Wi is the weight of the rainfall depth. Pi is the gauge I. It also the weight for station I is computed by Wi Ax over Nai. We have an example. It is the required is to determine the monthly precipitation at gauge X. So we have steps in determining the monthly precipitation using the normal ratio method. So the solution. Third is the inverse distance method. The missing rainfall data of the station X is being computed using the following equation, where Pi corresponds to the rainfall of the surrounding stations. X, Y plus Yi is the coordinate of each surrounding station, and coordinate 0, 0 refers to the coordinate of the station with missing data. So we have an example. Fourth is the regression method. It is regression analysis is a procedure for fitting an equation to a set of data. So we are making an equation that is fit for the set of data, specifically given a set of measurements on two random variables, the y and x. It provides means for finding the values of the coefficients a and b for the straight line. Y equals a plus bx, which is best fits the data. The coefficients a and b can be found using least square method using the following two equations simultaneously. So the two equations are on the screen. Example, the data. So the solution, develop the equation in the form of y equal to a plus bx. This is the monthly rainfall. The coefficients a and b can be found using these equations. Solution. To estimate the monthly rainfall for the year 1996, substitute the annual rainfall of the year in the equation and estimate the monthly rainfall in millimeter. So we have 240 millimeter. In summary, the different types of rainfall gauges are the graduated cylinder, the tipping bucket, the weighing precipitation, the optical rain gauge, and the acoustic rain gauge. They are used to measure precipitation in its liquid form in the specific area and predetermined period of time. So we have the conversion of point rainfall. The method for estimating aerial rainfall of an area from point rainfall. So we had the station average method, the Pearson polygon method, and the isolator method. So the last is estimating the missing rainfall data. The methods are first the station average method, the normal ratio method, the inverse distance method, and the regression method. That's all for today, and I hope that you have learned something. Thank you.